crazy, and I was like looking over the textbook, but I haven't gotten an opportunity to read the.
No, you're fine. Don't worry.
Okay. Okay. How are you though?
I'm good. I'm good. Just tired.
Yeah. Me too. All right. Let's do this. We have 14. Okay. Find the margin of error for a 90% confidence interval when the standard deviation is 50 and n is 25.
Yeah, so it's critical value times standard deviation divided by square root of n.
So it would be 0.9 times 50 over square root of n, right?
Yes. So it 1 point. No, so it's for the first one.
Mm-hmm.
We have sigma of 50 n equals 25. So it's
So we're looking for
50% interval, or when you have a 90% confidence interval, it translates into 1.64449, I think. So it translates into something weird, basically.
Oh, does it write it down? It probably has it somewhere.
Well, basically, the equation comes out as 1.64449 times 50 over square root
Of 25?
Uh-huh.
Okay.
Yeah. So basically, all of those confidence intervals, so like 90, 99.7, and what's the other one? 89?
Oh! Yeah, 68, 95, and 99.7.
Yeah, they all have a different like value. So I don't remember how you get it, but I remember it's like 1.99, 1.644, things like that. So basically, I just know.
Oh, I saw it. It says right here. Okay, perfect. Yeah. Most commonly used values for Z, which are in the 90s.
Yeah, so basically you have to put it in the area and you find an area. So
okay.
In the normal probability applet. So when you do 0.9, you find the Z-score, put it in. So it's 1.6449 times 50 over the square root of 25, which comes out 16.449. But if you do it two different ways, so if you round up the area to 1.645 times 50 and then square root of 25, you get 16.45. So I'm not sure which one.
I feel like the confidence interval would be the rounded one because like it has it in the textbook, so I don't know why they would lead us. I hope they wouldn't lead us astray.
Yeah, that's why I'm thinking it's actually 16.45.
Yeah. So should we put 450 because it says round to 3 decimal places, or just 6.45?
I don't know, because if we're rounding to 3 decimal places, I don't know. Because I'm not sure.
Well, I think I'm going to put a 0.
Yeah, and I guess if we get it wrong, we'll just go back and
take it off. Yeah. Which of the following statements is true?
Flip it. Ah! Stupid. I think it's the backwards U is a point estimator of mean is true.
I think so.
Yeah, that's what I'm thinking. Oh my goodness. Yeah, I think it's the U is the point estimator of mean.
Yeah. Okay, Jana wants to construct a 95% confidence interval for the GMAT score. She knows the standard deviation is 113. She collects a simple random sample of size n equals 64 and computes x. Uses this information for the next 6 questions. What is the point estimate?
It's a good question. I don't know.
I don't either. Mm.
The reason I got the answer for the first one was because I searched it and I found out how to do it.
Okay. Yeah, I normally watch the videos, but today's been crazy because I got home at 4 in the morning from Salt Lake because I went to a concert, and then I've just been doing things all day, and I didn't have a chance.
No, it's okay. I didn't have a chance to watch the videos either. I had to do stuff on my lunch instead of watch the videos. But this is actually working pretty well because then I can see how they solve it.
Yeah.
Let's see. So it says that point estimate for the GMAT score is given by population mean. It would be 526.
Yeah.
Yeah, so I guess the way you do the point estimate is it's just the population mean.
Oh, so it's 526.
Mm-hmm.
Oh.
And then it says for the margin of error, it's really complicated. It shows you how to do it. So, I mean, I don't know if you want me to like share my screen with you so you can see it.
Yeah.
Okay. Yeah, because it's going to be hard for me to explain this. Where? Mine. Share. Okay, I'll make this bigger. Okay, so see right here, this is the margin of error equation.
Okay.
Yeah, see how I was like, I don't know how I'm going to explain that. But basically, you do E equals the z-score. I don't remember what this little fish is.
I don't know. Actually, could you send me the link to that? Because
Yeah.
I can like see your shared screen, but it would just be easier to like see it at the same time.
You have to pay. I pay for Chegg. So
oh, just kidding.
Screenshot it. Would that be easier?
No, I can actually see it better now.
I zoomed in. So yeah. See how there's like a little fish?
Yeah, is that the sig? It's not the.
So this one is sigma. Standard deviation is sigma.
Yeah, but that's not.
Yeah. So I don't know what this guy is. I have no idea. I know it's in one of our equations because it's up here too.
Uh-huh.
I don't know what this is. I have no idea.
Margin of error in the textbook.
And I wrote it down too. I took a bit of notes. Yeah, it's sample size, confidence level, margin of error. It's right here. So I think that they did like a harder one. Why can't I zoom? So I can't zoom, but I have it right here too. It's like z times standard deviation square root of n. You see that? Margin of error.
Yeah.
Yeah, it's that one too.
Mm-hmm.
So you find the z-score and then take out these guys.
Mm-hmm.
Times sigma over n.
Okay.
1.96, put 113 over 64. Does that make sense?
What? Oh.
Yeah.
1.96 is the z-score, and then you get one.
You put the standard deviation of 113 over 64, which is n.
And then that's how you get the answer. Yeah, that makes sense.
I'm trying to figure out how they got the z-score, though, because I want to make sure I know how to do it. I don't just want to, like, look at the problem.
Yeah, so the z-score is the x subtracted by the mean and the sample mean are the same because they don't give you another, you know what I'm saying? Because they only give you the sample mean. They don't give you the original mean.
Well, because there are so many different ways to find a z-score. So this one is saying they found it from the z-table.
Oh.
Yeah,
Okay.
so I don't know
feel
what
like
the table is. So I figure that's how they're finding it. So that's how
yeah.
they're through a z-table. I don't know what a z-table is, so I think that's what they're talking about with what this signal is right here, this symbol.
Yeah.
So that's how they're finding that. That's what we haven't learned. We don't know what a z symbol is.
So actually, it reminds me of the textbook because I think that is supposed to signify the same thing as the asterisk in the textbook, where the z asterisk represents a calculated z-score corresponding to a particular confidence level, which must mean that you use the confidence level at some point in the z-score.
Okay, that would make sense. So
yeah,
you find the z-score. I just want to make sure you know how to find the z-score. So basically, you find the z-score and then you plug it into this formula. Disregard these two. So z-score of 1.96 with times 113 over square root of 64, and then you get the 27.685 for the margin of error.
Yeah.
Okay, that makes sense.
$27, right?
27.685.
Okay. What is the lower limit of this confidence level interval?
So this is how you find lower limit. So it's x minus e equals 526 minus 27.685. So e is the margin of error.
Okay.
Yeah, so you do lower limit is x minus e, upper limit is x plus e. Does that make sense?
Yeah, and the e is the margin of error, right?
No, e is margin of error. See, because I feel like when you look at the problems already like laid out for you, it is so much easier to understand. That's just my own. So
no, that makes a lot of sense. It's kind of like when you have a tutor.
Yeah.
And they just lay out the problem for you, and you're like, I'm so dumb. Why didn't I see this before?
Yeah, that's why I was like, this is so much easier.
Yeah.
Otherwise, I would have been like, it's probably some long explanation, but no, this is so easy.
Yeah.
Because then it's just the x minus e equals 526 minus 27.685. So that means the lower limit is 498.315. The upper
498.315.
And it's on my screen. I don't know if you can see that at all.
Okay. Yeah, I can. I just moved it over. Okay.
And then 553.685 is going to be the lower or upper limit.
Yeah.
And then to find what would happen to the width of the confidence interval, I don't know. I think that's probably in here, but I have no idea.
What happened if she increased the sample size? Well,
I think it shows you. Oh, it shows you right here. 95% confidence interval. Let's see.
Is
Oh, I know how they got the 1.96.
How?
For the 90 percentile. 95th% confidence interval.
Oh, okay, yeah. Yeah, I was imagining that you use those.
Yeah, because remember, you've got to factor in that 95%. I completely forgot about that. That's why she has the 1.96. I wish we had like a table with all of those in it.
Yeah, I'm sure I can get one from the math lab. I'm sure they have that. I haven't been yet this semester, and I need to go. But
yeah, but that makes total sense now because it's the 95% stands for the 1.96. So you don't have to calculate the z-score. It's the z-score is that 95. They already give it to you. But technically, if you put in the, oh gosh, I wish I would have known this.
Oh,
it's
factors affecting.
Yeah, it's the normal probability applet. You just put in the 0.95 and the z-scores right there.
Yeah.
Gosh, that would
also in the textbook right after, you know, that little table that has the commonly used values for the z-scores. Right underneath it says factors affecting the width of the confidence interval. So there's, yeah. So it's literally right there. And it gives you an equation. And I'm pretty sure we would use the z-score that we were looking at earlier, where it's the 1 point. It's the one that we use for the because the confidence interval for this equation is 95. So you would be using the 1.960.
Yeah, so I'm wondering what it would be if it was 99.
Yeah, but the thing is, like, I see where it is in the textbook, but I just don't understand.
Where's it at in the textbook?
It's 4.2 on the textbook, and it's right after the. But it's there, but it doesn't give you. So confused.
Oh, it's that super long. Yeah.
Yeah.
You have to put in all of this.
Oh my gosh. Okay. We can do this. It's just the same.
Confidence level 90. Okay, so you know then if it's 99, it's going to increase.
Yeah.
But if she increased the sample size, I'm not sure. So if she increases the sample size.
Okay. Factors. No. Interpretation of confidence requirements.
If we increase the confidence level, what happens to the required sample size? If we increase the confidence level, the required sample size also has to increase.
So it would increase.
Yeah.
Okay.
So both have to increase. So if we increase the confidence level, the sample size also has to increase. It doesn't stay the same.
Okay, and then it would probably be increasing for 10 too, because it said what would happen to the width of the confidence interval.
We can tell right here because it says what would happen or what would be required. Where'd it go? I lost it.
If we increase the confidence level, what happens to the required samples? No.
I'm going with increase because the 99 right here is 2.576. So if it's at 1.960, it's either going to increase or decrease. So, I mean, we can look at the equation and I mean, we can solve it. It's not super hard. So I go over here. I'm gonna go to Mathway. Gosh, I feel bad when they didn't have like internet and stuff like that.
I know.
Okay, 2.576. 2.576 times, oh no, not what I wanted, times 113 over square root of 64. 38.386, it's going to increase.
For 10, right?
Oh, wait. Well, for the confidence intervals are going to increase, yeah.
Okay.
Because your margin of error is going to increase. So therefore your confidence intervals are going to increase. Well, your lower limit's going to decrease because it's bigger. Your upper limit is going to increase.
Okay.
So, I mean, yeah, it's hard to say.
I feel like it would just increase anyways.
Yeah.
Okay. You want to know the sample size.
The sample size?
For question 11.
So he tells you how to do it. I just don't understand it.
Wait, could you zoom in so I could see it?
Yeah.
Wait, I can widen my screen too. I can also do this. Okay. So A, where is he getting
Oh,
A?
what sample size do they need?
Yeah.
1.96. That's 90, isn't it? 95? 95?
95, I think. Yeah.
Oh, they're looking for the sample size.
Mm-hmm.
Sample size formula. This is how he's doing it. So that's why I was confused. That's the sample size formula. And
Okay.
Z. I this one. I always want to make this one bigger and I can't. Okay. So it's Z, N equals Z times sigma over M. I have no idea what M is. Wait, didn't we just figure out what M is? No.
No.
Okay.
I don't think.
Root. So maybe he can help us figure out what M is. So N equals Z times S over E. But his are different, so I have no idea.
Oh, E! Margin of error.
Oh, it's just marked as M in our.
Yeah.
Yeah. Thank you, Chegg. Yeah, so it's 1.96 times 400 over 500 squared.
Mm-hmm.
So you basically end up getting 245.8624.
Which is 246.
Yep. Because you're rounding.
Mm-hmm. Okay. The mean salary of actuaries is mean of that. Is that if you're interested.
It has literally all of these.
Wow, that's so nice.
Yeah. So nice.
Especially because it like walks you through it.
I know, that's why I was like, it's actually very nice because unfortunately, because we're online, we don't have a teacher that teaches us. Well, like she teaches us, but not like every single problem.
Yeah.
Let's see. Given 0.05. Let's see.
Oh, because it gives you the A. So I was like, where did they get that?
Yeah, that's what I was trying to figure out. I was like, how did he get A?
Yeah, but they give it to you in the problem.
It's just a lot of talking, I guess. Oh, yeah, it's right there. I was like, where did he get it? Oh, it's right there. Z is 0.025. I don't know how he got that one, though.
The Z-score. So he probably did 100,000 subtracted by the 111. So it was 111 subtracted by 100 divided by 36.
It's a 95% confidence interval.
Oh.
Yeah, that's how he got the 1.96.
Oh. Oh, yeah. Okay, yeah, that makes sense, yeah.
Yeah, and then we know how to do the confidence interval. We have to find the, what is E? Meaning of error. Margin of error. So we did the margin of error, found the lower limit of the 95% confidence interval by doing that.
Mm-hmm.
I don't know what X bar is.
I also don't know.
Yeah, because these formulas are getting more and more intense. So now I'm like, I don't know.
Yeah. I don't know.
Wait, I think I have it written down in my notes too. Equation for confidence interval. Yeah, because look at how long that is.
Yeah. That's a lot.
Yeah. Yeah, because the margin of error, this is super small, I can barely see it, is M equals Z times sigma over N,
Mm-hmm.
where Z represents a calculated Z-score corresponding to a particular confidence level.
Oh, which are the three z-scores that are the 90?
Doing right now. So he's doing the z over n. So it's like 111,000 minus 1.96 times 36,730 over 36.
Yeah.
A lot of math. So basically, the lower limit is 900 or 99,002. So much. And the upper limit is 112 or 122,999.
Okay.
There are three
requirements. We checked when computing confidence interval for a mean. They are all of the above.
That's what I was trying to find. I don't know.
I think it's all of the above.
X is normally distributed. Sigma is known, and a sample is random drawn from the population. I mean, that seems right to me.
Yep. All right, I'm submitting this.
What is submit quiz?
85. I'm good with that.
Yeah, I'm good with that. Because, I mean, they're almost all right. I think there's... Oh, it was just our answers.
They weren't round.
Yeah, that's all right. Oh, well. There were two that were wrong. It was question 4 and question...
And then in question 7 and 8, I got half.
Question 7 and 8?
Yeah. And then I also got half for the other ones.
Yeah, it's only worth 0.5.
Yeah, but I'm just curious, like, what the number was before. Because, you know, they, like, gave you a number, and they didn't really... And, like, at what point you were supposed to round it. But I don't know. I'm good with this.
Yeah.
Good.
Well, I can show you, because the math is here. It's just 111,000 minus 1.96. So it's,
okay.
Or it's X bar, which I think is one of these guys.
Uh-huh.
Oh, it's right here. That's what he's writing, X bar. Okay, I was so confused.
Oh.
Yeah.
What the heck is that? Yeah.
I was like, I've never learned about that. It's the mean minus Z times S, so sample mean, over VN. What is VN? I'm guessing it's square root of N.
Yeah. Yes. Yeah, because
the significance.
Yeah.
Yeah.
Okay.
Interesting. Well,
good job. Wait, we didn't even introduce ourselves.
I don't know how it's working. I can't find you. Where did I put your window? Okay, there you are. I don't know honestly how it's working because I got an email from Justina the other day.
Yeah.
And she was like, yeah, you're missing 3 different group quizzes. Were you there? Because I'm pretty sure you were. And I was like, yes, I was there.
Yeah.
I thought so. And I was like, yep. Yeah, I have no idea how they're grading them because I don't think they're watching them necessarily.
Okay.
They're just like looking at who was in it. So I think that's why I texted you and I was like, can you just make sure you're writing it? Because I don't think they're watching them.
Okay. Yeah. What group are we again? 13?
Yeah, group 13.
Okay. That's what I thought. And that's what I wrote down. But I was just like, I hope this is right.
Yeah.
But next time I'll type in like when I do conduct or do whatever, I'll type in our names too.
Okay, yeah, that sounds good. I just didn't think it would be a problem, but I think it's because they don't have time to watch all of them.
Yeah, that's a really time consuming.
Mm-hmm. And so I think that's why. Okay.
Can
you just write down your names?
Yeah.
Mm-hmm.
Perfect. Yeah. All right. Well, see you. Thanks.
All right. I will see you Thursday. Bye. Bye.